Dear students, today we are going to discuss Kirchhoff's voltage law. States that in any electrical network, the algebraic sum of voltages around a closed loop is equal to the zero. Let us consider a simple example. Two resistances R1, R2 connected in parallel are excited. Two resistors R1 and R2 are connected in series and they are excited with a DC voltage source plus V volts, and the current flowing through resistance is I. Now the voltage drop across R1 I am taking as V1, and the voltage drop across R2 I am taking as V2. The current entering terminal is taken as positive for the voltage drop, and the current leaving terminal in the resistance is taken as negative for the voltage, negative polarity for the voltage drop. Now if you write the loop equation here, the current I is the loop current. Now if we start from here, first we are going to come across a voltage drop. Now I am taking the voltage drop as negative and voltage rise as positive. Here the voltage drop is appearing in resistance R1, so the voltage drop is R1 into I, and next drop is R2 into I. Next is when you come across here, we are going to have voltage rise, so it is plus V. As it is rise, we are taking as positive, equal to 0. So if you multiply with negative side, we are going to get R1 into I plus R2 into I minus V equal to 0. And if you move that minus I onto the right hand side, we are going to get R1I plus R2I equal to 0. This is the KVL equation for this loop. Okay. Now in terms of voltage drops V1 and V2, the same can be written as R1 into I is represented with voltage drop V1. So V1 plus R2 into I were taken as V2. V1 plus V2 equal to V. Now in order to find out the current, the loop currents, we are going to use mesh analysis. Now let us take a simple example. Here I am taking a T network. Here resistance is R1, resistance is R2, resistance is R3, is voltage, and this loop current I am taking as I1, and this loop current I am taking as I2. Now I want to find out the I1, I2. For that we need to develop the loop equations by using KVL. So first, for this first loop, here we are having two loops. This is first loop and this is second loop. So for loop 1, if you write the loop equations, these are given by R1 into I1, the voltage drop in R1 resistance, then we cross R3 resistance, R3 resistance is having R3 is a common resistance for the loop 1 and loop 2. So the currents I1, I2 both are flowing through the resistance R3. Now as we are considering the loop 1, we need to follow the direction of current I1. So the direction of current I1 is clockwise, and in R3 the current is flowing from top to bottom, and when if you take the I2, I2 is flowing from bottom to top in the resistance R3. Therefore, the net current flowing through the R3 is given by I1 minus I2. That will be equal to voltage V. Sum of voltage drops equal to voltage rise. So, R1 I1 plus R3 I1 minus R3 I2 equal to V. So, if you take I1 as common, then R1 plus R3 into I1 minus R3 I2 equal to V. So let it be equation 1. For loop 2, if you write the equations, if you start from here and move in clockwise direction, R2 it is involved in loop 2 only. So R2, and the loop current is I2. So the voltage drop is R2 I2, and then we come across the resistance R3. R3 is a common resistance for loop 1 and loop 2. So voltage drop will be R3 into I2 current. As we are writing the loop equation for loop 2, we need to take the direction of I2 as the reference. So I2 is flowing from bottom to top, that we have considered as positive, but I1 is flowing from top to bottom, so it is opposing the I2. So net current will become I2 minus I1 equal to, there are no voltage rise, so it will be equal to 0. So R2 I2 plus R3 I2 minus R3 I1 equal to 0. So rearranging the terms, we will get R3 I1 plus R2 plus R3 into I2 equal to 0. So on solving equations 1 and 2, we will get I1 and I2. So equation 1 is a equation which contains two variables I1 and I2, and equation 2 is also having two variables I1 and I2. So we are having two variables with two equations, linear equations. Therefore, by solving these two linear equations, we are able to get the I1 and I2. Let's take an example problem. Let us consider a three-loop network. Let it be 10 ohms. It is 5 ohms. It is 12 ohms. It is 18 ohms. It is 30, and it is 20 ohms. It is excited with 400 volts. Now let us take this current is I1, this loop current is I2, this loop current is I3. So there are three loops, loop 1, loop 2, loop 3. Now let us see how to write the loop equations. Loop 1. So our requirement is we need to find out the loop currents I1, I2, I3. Now loop 1 is this one. Now let's start from here. So these two are resistances. So we're having voltage drops in 10 ohms and 20 ohms. Now 10 ohms is considered, 10 ohms is linked with only loop 1. So 10 into I1, and 20 ohms is linked with loop 1 and loop 2. It is common resistance for loop 1 and loop 2, and it is going to carry the currents I1 and I2. So I1 is flowing from top to bottom, I2 is flowing bottom to top. So it will be 20 into I1 minus I2 equal to 400 voltage rise. So 10, here is one more I1 term, so 30 I1 minus 20 I2 equal to 400. This is equation 1. Now if you see for loop 2, for loop 2 is 5 ohms resistance, 30 ohms resistance and 20 ohms resistance form the loop 2. Here 5 ohms is convert to only loop 2. So 5 into I2, and then 30 ohms. 30 is common resistance for loop 2 and loop 3. In 30 the currents I2 and I3 are flowing. I2 is flowing from top to bottom, I3 is from bottom to top. So the net current is I2 minus I3. Next we come across resistance 20, so plus 20. So 20 is common for loop 1 and loop 2, is going to carry I1 and I2. So the current is I2 minus I1. As we are considering for loop 2, I2 has taken as reference. So the I1 terms are minus 20 I1. Next I2 terms 5, 30, 20. So total 55 I2. Next I3 terms minus 30 I3 equal to 0. This is equation number 2. Now if you write for loop 3, loop 3 is formed by 12 ohms, 18 ohms and 30 ohms. So 12 ohms, 18 ohms are belongs to only loop 3. Therefore 12 I3 plus 18 I3 and 30 ohms. 30 ohms is common resistance for loop 2 and loop 3. So 30 into I3 is reference current, I3 minus I2 equal to 0. So if there is no I1 term, I2 term is minus 30 I2 and I3 term is 60 I3 equal to 0. So these are the three equations that we can develop for the 3 loops. So here we are having 3 equations. First one is 30 I1 minus 20 I2 equal to 400, and second equation is minus 20 I1 plus 55 I2 minus 30 I3 equal to 0. Third one is minus 30 I2 plus 60 I3 equal to 0. So we are having 3 equations, and with 3 unknowns I1, I2 and I3. Now if you solve these 3 equations, then we can get the I1 value, I2 value and I3 value. Okay. For solving we can use the matrix form. 30 minus 20, I3 term is 0, I1, I2, I3 equal to 400. Next, second equation, I1 coefficient is minus 20, I2 coefficient is 55, I3 coefficient is minus 30, it is equal to 0. 0 I1 coefficient, minus 30 is I2 coefficient, plus 60 is I3 coefficient, it is equal to 0. If you solve this, we will get I1, I2, I3. So it will be, if you do on your own using calculator, you will get the value as I1 is 20 and I2 as 10, I3 is 5. Okay, thank you.